Hello, welcome everybody to my talk, Escaping the Phantom Zone of Insecure Data, Build Safer Applications with Zot. Zot is an NPM package for schema declaration and to validate your data. My name is Philipp Gentz, and I'm a team lead and developer at Synaptics. Synaptics is a venture builder, and it embarked on its journey in 2008 and has since grown to over 150 skilled professionals and nurtured over 30 startups and is located in 5 locations, even Mallorca and Hamburg, Berlin, Dresden, and others. And my team is currently focused on credit.de. Credit.de quickly became one of Germany's top credit brokers. It works with over 500 banks and institutions to cater a diverse array of needs of financing solutions. And we get a lot of data from it, from our customers. Again, ringing a little bit late. And our data comes in all shapes or forms because our customers are very different. Some live for rent, and then we need to know how much rent they are paying. And maybe they own their house, maybe they're renting it. So the data comes in all shapes and forms, and we need a very potent schema declaration library to validate that data. And while there are many libraries out there that can validate that data, not every library helps you during the development of it. I'm gonna take a sip, I'm sorry. So my agenda is sort of like a history of credit.de, where we just talk about data validation and a little bit of data security and why it's important in the space. We quickly go over JavaScript and why it's important to validate data there, because it doesn't really help you there. We go quickly over TypeScript and how it can help with the shortcomings that JavaScript has. And then we'll get into the gist of Zot, look at Zot's API, look at some examples, how it can help you. And later we draw some comparisons between alternative schema declaration libraries. So let's get into it. Well, data validation is very important, and that should be obvious, but it's also very important to have it at the edge of your system. So when data comes into your system, you want to validate it, and not later when you try to save it to your database, because it will be difficult to find out what went wrong. So to prevent errors, a schema declaration library can help there, obviously. But it will also improve user and developer experience, because you get immediate feedback, of what went wrong and where did the data come from, what shape did it have, and what was missing. So that helps during development too. But it also helps with data security. By preventing malicious users from entering invalid data, you can stop attacks. So that's important. And while JavaScript's dynamic nature helps with rapid prototyping, it also is kind of a downside, because its dynamic typing allows a variable that was once a string suddenly to be a number or an array. And suddenly you're trying to add 2 numbers together, but one of them is a string, so you get an invalid computation, which leads to potential issues and errors. But it also makes code less readable. If you don't know the data type or data structure of a variable, you kind of start this file switching to go through every file, make sure what the expression actually returns, and your IDE can't really help you in JavaScript very much. So it makes errors difficult to find when they occur, because you don't know what went wrong. So I'm not really a TypeScript zealot, but I feel a lot of people expect you to be as soon as you start using TypeScript to only talk about TypeScript and static typing. I'm not one of them, but it does add its advantage when you have a lot of different data, and your IDE can help you identify what is available on that data structure. So for those that don't know, TypeScript adds static typing to JavaScript. So it's just a superset. When you compile your TypeScript, you're just getting JavaScript out of it. So you also, what you gain is code completion. Since you define your data structures, your TypeScript knows what your data might look like and can help you identify what structures, what data types are on that property. So it's also sort of self-documenting. Since you know what is on it, new developers can... Let's wait a second. So it's sort of self-documenting. Since you can drop in new employees or come into a new project and immediately find out what the expression does because you know your IDE can tell you what properties are on it. But its type safety is not really there because type safety, so TypeScript operates in what is sometimes called type land, which is not real. It's only during the development, and after you compile it down to JavaScript, the only form of type safety that you get is because TypeScript makes you work for it, because it makes you double check that the variable is not undefined or null, that the expression is really there, so you kind of forget that this undefined is not a function even existed in the first place. So there are two ways where how you can define types or get TypeScript to work. First is by inferring a type. So when you declare this person object, we give it two properties, first name and last name, and both are of type string. TypeScript then knows from the context that this object has these two properties. The advantage is you don't really have to maintain this type. By explicitly declaring a type, in this case a type person with first name, last name properties and both of type string, we can explicitly say this variable is of type string, and if we don't pass in these two properties, TypeScript will tell us, give us a compilation error, or in the IDE tell us, you're missing a property here. But it's important to note that you need to maintain this type. You need to make sure that this typeland structure, this interface, represents the structure of the runtime, because they might drift apart, and that leads to errors. I'm taking another sip. So while you are inevitably declaring types because you're going to be using them throughout your project, it's usually better to infer them and basing them on runtime structures. And that's sort of what Zot can do. But first, something about a discriminated union. A union is an OR type. So a variable might be a string or a number or an array or whatever you want it to be. So for this employment type, which is very important for Kredite because we have a lot of customers who are either employed or freelancers or officials or what have you. So in this small example, the employment can either be an employee or a retiree. And our retiree type looks like this. It has an employment type, which needs to be of type string, and the string needs to be retiree. So it's not a string, it needs to be the string retiree. And then we have a pension property and a retired since property. So in the discriminated union, you need a discriminator, which needs to be available in every variation, so you can narrow down the type. In this employee type, we have the same employment type, but it needs to be the employee string and a couple of different other properties. So when we check in our IDE a data of type employment, and we check the employment type property and check it if it's equal to the employee, TypeScript then can narrow down the type from employment to type employee and give us great autocompletion because it knows these properties will be on there. But we explicitly declared this type and didn't really make sure that the runtime structure is the same as the typeland structure, because it might not be true. It's just what we told TypeScript it is, which comes in Zot. Because Zot, as I mentioned, is a schema declaration library, but it is very powerful and simple. It's very flexible and reliable. and it can generate your types for you. Based on your schema declarations, it generates types, which you can use throughout your project. What really sets it apart is its support for discriminated unions and unions in general, because other schema declaration libraries do not have that kind of support. So it becomes your bridge between typeland and the runtime, because you base your structure, your runtime structure, your typeland structure on the runtime. So they can't drift apart. So let's have a look at some API examples to show you how simple the API is. So if you are familiar with the builder pattern, Zot starts with the Z import. So you import just Z from Zot. And then you can just start typing. So we declare a schema. And on the Z property, we have a lot of different properties. The most important would probably be for us the object property, which just means when we declare it and later call parse on it, it will expect a data property, and the data is unknown until then, because you never know what you're passing in. It might be invalid, or it might be the output that you're expecting. What makes Dot really great for this, and other libraries do that too, it will infer the property here based on what your schema declaration is. So it's just an empty object, not really useful. So let's just add an employment type and make it a Z string. So now it knows the data is an object with the employment type property string. Well, if you call parse and the data is invalid, it would throw an error. So that's why inferring, because it would never get to that part, to the data part, because it would throw an error. So let's kind of expand it. We also have maybe the pension property, which let's make it a string for now, because that lets you do other kind of function on it. For instance, it lets you do a refine property, where you can check additional functions or give it additional functions to check against. So for instance, we might check if the number is none and pass in the value to check if it really is a number. But maybe we don't want it like this. Maybe we would want to call transform it and just give it the number constructor. So TypeScript then would know it's now a number, because after the parsing, it would also transform the value from a string to a number. And if it couldn't do that, it would throw an error. But Zot has you covered there, because it was, for us in the front-end development, a lot of part where we just refine, cast to number, refine, cast to number. Zot has you covered there by the coerce property, so it tries to coerce the value from a string to whatever you want. Oh, I mistyped. So then we can just do a number, and we would see now it's a number. But we also have the retired since property, which is a string or a date, but it can also be coerced to a date, because if you have an ISO string, it can be a date. So that's very basic, and a lot of schema declaration libraries until this part got you. It's just the same. It can, the type generated by the other property, other libraries are basically the same. What sets Zot apart is a discriminated union. So it has not just an object, but also a discriminated union, where we need to declare the discriminator, which in this case is the employment type. And then it expects an array. So let's make this an array. And this is an Zot object. Let's just start again. Copy this. So we have our first discriminator, and let's add another one. And we know that the string of employment, the employment type of string is not correct. Well, is there still an error? That's why you don't do live coding. Let's quickly do it again. So it even gave us IntelliSense here to, because it knows it needs an employment type, and we don't do a string, but we do a string literal, where it expects the retiree. And we are going to do this here down here with the employee. And now we can add our properties. So the pension is coerced to a number, retired since, the date. We don't coerce it for now because just to quickly get you. So a company name is also a Z string. And if we validate the data, we would see it give us this union. And we can then generate a type by calling Z infer and give it the type of the schema, which we can then reuse throughout the application. And if we would check data here and the employment type, it would give us the autocomplete, and it would then know that the company name needs to be available, because we based our type generation on the runtime structure. So we don't have to maintain our type. So Zot has a lot of different functions for you. It has, of course, a Boolean, it has a tuple, it has a record, it got you covered. So the basic API is pretty much the same for every other library as well, but Zot has a discriminated union. So Zot's API, very flexible, but most of it available in other applications, libraries. But, well, how about some examples? So for the front end, we, again, have a lot of choose your own adventure. So you need to choose your employment status and give it data, or give it the employee and then give other parts of data. And does anyone know React hook form? It's a very popular library for state management and for React for forms in React. It kind of grew more popular than Formic in the recent years because it gives better performance in general. So Zot also has a resolver for Zot. So React hook form also has a resolver for Zot. So we can paste in a Zot schema, and it will use that for the validation. So when I click here next, it will validate our schema, and we get errors. If we use the retiree, it will also give us these errors. And in the onSubmit method, it will also force us to check the employment type property before we do anything with the data. Because, again, great discriminated union support. Another very important part that you can do with Zot, which I don't see a lot of people doing, is checking their own API responses. So even if I write my own API, I still like to make sure that the API is correct by validating the response, because even though you might get a 200 now, maybe you get a different response in a couple of weeks. And most of the time, it's might be easy to check just a type of property and see if it's a string, but sometimes you get a nested structure, an array or whatever, and it gets complicated. And Zot is very small, it's like 10 kilobytes, so you can even ship it to the front end. So here we have a small usability improvement for our user. So if you give it a zip code, it calls an API, which just returns a string, and we can then set it to the location property, to the city property. But I'm going to change the endpoint now to something else, and suddenly we made the UI, the UX for the user worse, because suddenly we are getting back in an array of object which has a string. So with Zot, we can just quickly check the response and validate it, and if it throws an error, we don't do anything, and if it passes correct, we can just use that. So we can just validate, write a quick schema. So in our case, we are expecting an object with just a single property of name city, and it needs to be a string, and it shouldn't be empty, because strings, this is also a string, but it's empty, and usually it's something that you don't want. But since we are expecting an array, we are going to do this, and just calling the array and passing it in the schema city. So now when we pass our response here. Let's call it city, schema cities, parse, and give it the JSON body. So now we get the IntelliSense that we expect. Cities is an array, and if we would try to access the first array index, we would have the city property, but we didn't really check if the array is empty or not, because an empty array is still valid an array. So what we can do is call in min1, so it needs to be have at least one element. Let's do max1, 2. Though Germany has postal codes which are for multiple cities, we don't really care for now. And what we can then do is do a transform and just return the first element, city. So now our schema is not an array anymore, but just a string. So we just give it back to the schema and our application works again. So with just a few lines of code, we made our UI UX better for our users, while also making sure that we don't pass around invalid data and might break our application. So there are obviously more examples. And at Synaptics, we are pretty much always hiring. And so I get to look at a lot of CVs. And some of the CVs have GitHub profiles on it, so I might click on it. And just a bit of advice, add a README. I go through so many projects and they never have a README. So I usually just scroll through the code and I might clone it and try to run it. And most often than not, it crashes immediately because they forgot to give me an environment file example. So I dig through the code, I check it. Yeah, I need to pass in this database property. It works. So I might send a request and then it crashes again because obviously on startup you don't validate most of the time you don't validate your environment properties, and they might be only necessary during the runtime of your process, and then it crashes because you forgot to paste it in. So with that, what you can do in the Node project, we can do it for the front end too. We can create just an environment file, and you can call it what you want, and where you just declare your schema, and then just parse the process environment. And when we use it, we just import the file. And on startup, well, this runs because I still have the environment file, but if I would delete it, it shouldn't run. So now I get an error that I need to pass in the database URL and so on. But let's clone this file. Maybe we should just. So if I give these properties back, it should work again. No. Let's give it 3000. Yeah, like this. So now it works again. And what you also might use throughout your application in process environments is on this exclamation point, because Node.js doesn't know what environment variables you are going to have. So usually you might do this one. What you can do with Zot, which I like to do, is just import the app environment, and on it I will have the properties like port and stuff, and then I can just use them. What others like to do is override the type from the namespace Node.js with the type of the schema. Because you defined your schema, you can infer the type from it and then sort of extend the process environment. So when we now check the process environment, we know it has to have the port and the database URL. But it doesn't really protect you, because when you don't import the environment file like I do here, it never gets parsed. So this approach I like better, but to each its own. Another way we like to use Zot is for our Express middlewares. So we can just do a very quick Express middleware based on the Zot schema. So the TypeScript looks a little bit weird because Express has a lot of properties it passes around on the request, on the response, and so forth. And we need sort of to keep them, because if we have multiple middlewares in the chain, we need to extend them and not just overwrite them. So here we just get a bunch of generics. Again, don't really look at them, but we just pass the body and then call next on it. So it's very simple. And if you look at here, we got it typed again with our properties. And if we pass in a different schema, like a Zot string, it tells us, this is not available because request body is just a string. But Zot is not just a library for TypeScript. It can also help your JavaScript project if you're so inclined to do that. Because it has such great TypeScript support, you can even write JSDocs, which seems to be a lost art because a lot of people don't write it anymore, apparently. But JSDoc also has support for generics. So we can quickly write a function, return schema parse on the data, and then write a little bit of JSDoc. So we need a constraint. Well, we don't need it, but I like to give it a constraint. And let's just call it tschema. So the template is the generic part. So based on the context, the schema, we infer what kind of type it is. So tschema. And the data can be anything. Let's just say it unknown. And in returns, the infer, again, our type. We infer the type from the schema. So when we now use our parse method and paste in the schema, which we defined up here, we again get our amazing autocomplete, even in JavaScript project. Still a minute. Comparisons, because we do need to talk about comparisons. There's obviously yup, which was kind of the schema declaration library that we used to use. It kind of fell out of favor, I guess, for Zot, because as you can see, Zot became more popular, and I think it's still growing in popularity because of its amazing TypeScript support. But we also need to talk about another library, which is just huge, which is AGV. So AGV is based on the JSON schema, which is a standard. So it's used like crazy. But if we just look at some examples where you need to define the schema, it really depends on the kind of project that you're having. Because if we are going to look, for instance, at our Zot schema, you can see in the same code here, can't even see it properly. So this is the yup schema here on the right side, and on the left side, we have the Zot schema, which I just think it's a little bit more verbose. So we see we have this project object and this object. And on yup, we have always to call this when method. So we have our employment type, so our discriminator sort of, but yup doesn't have discriminator support. So it's one of either the employee or the retiree. And then we have, for instance, company city, which is a string. But then we need to check if the employment type is of type employee, then the schema is required. And we have to repeat that for every single property. So you write a lot of extra code, and you don't get the IntelliSense or the generated type that you actually want, because it can't help you there. So for AGV, there are two ways to define your schema. First, the JSON schema, thus just this JSON file. It's very popular because it's based on a standard. So you can give this JSON schema to someone who writes PHP code, and there will probably be a library there that can use that JSON schema. And for pretty much every other language. And I think it looks a lot like our Zot code. So it's one off, and then we have the type object with these properties, and then we have another properties, type object, and it has these required properties. So from the code, it looks a lot similar, but you have to write your own type again, which you need to maintain, which when you forget it, well, you will get a runtime error. I did that once. It's annoying. But there's another way that you can write it now. There's the way to write it as a JSON file, as a TypeScript file, but it's basically just copy-pasted the JSON here inside the TypeScript file, and then you still need to pass in your own type schema. So not really an advantage. So to sum up, AGV, very popular, very great if you are expecting to pass the JSON schema around to a lot of different projects and who use a lot of different language. But if you're deciding between Jup and Zot, please choose Zot. It helps you immensely by not having to redefine your own types. So this is my time pretty much. Hope I did good. Yeah. Thank you.